Hey guys, my name is Yash and welcome to my channel Real World Stats. Today I'm going to talk to you about the statistical concept of z-scores and normal distributions using a practical example of how percentiles on the SAT are calculated and what they mean. So let's get started. The SAT is a standardized test used by American colleges for admission. Your SAT score is divided into two sections, a math section and an evidence-based reading and writing section. For each of these two sections, you can score anywhere between a 200 and an 800. The scores which you receive on these two sections are then added up to give you your final composite score, which lies between 400 and 1600. The graph on the right shows you the SAT score distribution of all the students who took the SAT in 2019. Based on this data released by the College Board, we see that the majority of students scored between 1000 and an 1190, whereas a lesser number of students had scores on either of the two extremes. Furthermore, the mean SAT score in 2019 was a 1059 with a standard deviation of 210. So before we start talking about the numbers, what exactly is a percentile? To explain this concept, imagine that 10 circles are placed in ascending order of their size. From the given figure, we see that the blue circle represents the 8th biggest circle. This means that 7 out of 10 or 70% of the circles are smaller than the blue circle. Another way to put it is that the blue circle is bigger than 70% of the circles. Hence, the blue circle represents the 70th percentile. Essentially, a percentile is a given percentage of data that lies below a certain value. Percentiles are very useful on the SAT because they tell you how well you performed relative to the others who took the exam. Hence, it serves as a means of comparing two students' scores. Also, if you took the SAT multiple times, it helps you to compare your performance on two different test dates. Now that you know what a percentile is, how exactly do you find your percentile? In order to do so, you first need to find something called the z-score. A z-score is a number of standard deviations a given value lies away from the mean. To explain this concept, let's consider a normal distribution. A normal distribution is characterized by a bell shape. It is unimodal, which means that it has a single peak, and it is symmetric, which means that if we draw a line in the center, it divides it into two equal right and left parts. The mean, or the orange circle in this case, is present towards the center of a normal distribution. The blue rectangle represents the data that lies one standard deviation away from the mean. From our definition of a z-score, we saw that it is the number of standard deviations a given value lies away from the mean. In this case, since the blue rectangle lies one standard deviation away from the mean, it has a z-score of +1. Similarly, the purple rectangle also lies one standard deviation away from the mean. But in this case, it lies towards the left, and hence we have a z-score of -1. An easy way to remember the positives and negatives of z-score is to find where the data lies relative to the mean. If the data lies to the right of the mean, then it has a positive z-score, and if it lies to the left, it has a negative z-score. The z-score can be also represented by the mathematical formula shown in red. In this case, x represents our given value, mu is the mean, and sigma is the standard deviation. This formula will become much clearer once we work with an example. The picture on the right shows you a sample SAT score report for a student. From this picture, we see that the student scored a 1010 out of 1600. So let's try and find the percentile for this score. From our last slide, we know that the z-score equals given value minus mean over standard deviation. So in this case, our given value is 1010 because that's the score which we're trying to find the percentile for. We have two unknowns, which are the mean and the standard deviation. However, from the SAT score distribution in 2019, we found out that the mean score was a 1059 with a standard deviation of 210. Plugging in these numbers in our z-score formula, we get the z-score equals 1010 minus 1059 over 210. And this gives us a final z-score of negative 0.23. Since this z-score is a negative value, we know that this data point lies 0.23 standard deviations to the left of the mean. Now we're just one step away from finding out our percentile. To do so, we need a table called the normal probability table. This table shows us the probability of data that lies below a certain value. Let's explain this using an example. The graph on the left shows us a normal distribution with a z-score of 0.667. The area in red shows us the probability of data that lies below this z-score. To find this probability, we use a normal probability table. The blue rectangle represents the first decimal point of the z-score, and the purple rectangle shows us the second decimal point of the z-score. Since our z-score was 0.667, let's round it to 2 decimal places, which gives us 0.67. The first red rectangle shows us the first decimal point of this z-score, and the second red rectangle shows us the second decimal point. The point of intersection yields a value of 0.7486. This 0.7486 is the probability of data that lies below a z-score of 0.67. Another way to put this is that 75% of the data lies below the z-score of 0.67. From our definition of a percentile, we saw that a percentile is the probability of data lying below a certain value. Hence, a z-score of 0.67 corresponds to the 75th percentile. From our calculation of the z-score in the SAT example, we got a value of negative 0.23. So let's go ahead and find the percentile of the z-score using the normal probability table. The first rectangle in red shows us the first decimal place of the z-score, which is negative 0.2. The second red rectangle shows us the second decimal place, which is 0.03. The point of intersection gives us a value of 0.409. This means that 41% of the data lies below the z-score of negative 0.23. Hence, a z-score of negative 0.23 corresponds to the 41st percentile. A score of 1010 hence corresponds to the 41st percentile. From this picture, we see that our calculated percentile exactly matches the SAT user percentile mentioned on this SAT score report. From the graph on the right, we see that higher SAT scores of 1400 to 1600 and lower SAT scores of 400 to 600 have small percentile changes, but intermediate SAT scores of 800 to 1200 have large percentile changes. So why is this the case? Why isn't the graph of SAT scores versus percentile a straight line, but instead it takes the shape of a sigmoidal curve? Based on the information you learned today, can you think of why this is the case? If you think you know the right answer, go ahead and leave a comment in the comment section below, and I will be revealing the answer next week.